All right, this for a little while will be the last section that's directly from your textbook. This is also one of those topics that will reappear later in Unit 1 when we get to AP content, that will pull back in some AP style questions on inverses, but we're going to do this one from WebAssign and then again from your book. On Monday, I'm going to create a whole new module, you'll see, and it will be labeled AP, and then unit whatever. So 1.1 we'll be doing Monday, and that's going to be from the AP content. So this is inverse functions. You've done inverse functions before in Algebra 2. I think you did. I don't know if Siri's right or not. I think that you did do inverses in Algebra 2, but obviously if not, this is your refresher. We talked about it already, but make sure that you are joining the AP Classroom. You're doing the class code, which is on the assignment that is due on Monday, and then you're screenshotting it and you're submitting it for an assignment. So you need to be in there by Monday. All right, so what is an inverse? Okay, if G is an inverse of the function f, then one way you can test it, so if it says, is G the function of, or an inverse of f, or is f an inverse of G, then the way we find it is the composite of them. So we do f of G of x and G of f of x, and when you do these, they should simplify down to just an x. You're going to see these a couple different ways. One, verify that it's the inverse, so you literally have to do f of G and G of f and show that they both would result in x. And then the second is it will actually ask you to find it. The symbol for the inverse is this f negative 1 of x. So when you see f to the negative first power, that means that is the inverse of f of x. So if I was saying G of x and then I wanted to find the inverse of G of x, it would be G negative 1 of x. So that's how we denote that it's the inverse to it. We're going to do these algebraically. You can do these with coordinate points. We're going to do this from a graph. All that stuff can be done. This first example says, use the inverse function property to show that f and g are inverses of each other. So it's already telling you that they are. The way we show it is by doing f of g and g of f and showing that they both result in just x. So if you look at A, if I'm doing f of g of x, then I take the g and I plug it into the f. So I'd get f plus 6 minus 6. The positive 6 and negative 6 cancel, and I get just x, which is what's supposed to happen. And then I have to do it the other way. G of f of x. I take the f of x, I plug it into g, and I get x minus 6 plus 6, which also results in x. So I would say this is helpful two ways. One, if it explicitly says this is what you have to do, like show it, means you have to do the work. Two, if it asks you to find the inverse, this is the way you check to make sure you got it right. You can always find the f of g and the g of f, and it should give you just x. All right, B, same thing except this time, well, the spacing is off. Obviously, this goes here. We're going to talk about the restriction in just a little bit because we're going to talk about why that's important. It is. We're going to ignore it for now. But in a little bit, we're going to come back to it and talk about why that's important. So right now it says, wait, I didn't mean to erase the whole thing, but sorry. Just this part. We're going to come back to why that x is greater than negative 3 is important. So I'm going to start the same way. I'm going to find f of g and g of f. So the first one, I'm going to take the g and plug it into the f. I get the square root of x plus 3 squared minus 3. What happens when you square root? Goes away, and I get x plus 3 minus 3, and they cancel. Then I go the other direction, g of f, so I'm taking f and I'm plugging it into g. I get the square root of x squared minus 3 plus 3. These cancel, and I get the square root of x squared. What happens when I square root the squared? It cancels out again. So technically that is absolute value of x, but we'll come back to that later when we start to talk about the restrictions. Question so far. So already it's saying these are your inverse functions. Just show me. But that's going to change in a little bit. Okay, now it's find the inverse. There are 4 steps. The first is replace f of x with y. Those mean the same thing. So we literally change f of x to y. The second is switch the x and the y's. If there's more than one x, they all become the y. If there's more than one y, they all become the x. The third is solve for the new y. And the last is we can't leave it as y because we changed it. It no longer is the same function. So we have to show we changed it to the inverse by putting the f negative 1 of x in place of the y. All right, so start with A. It says find the inverse function of f. Step 1, replace y, or replace f of x with y. Step 2, switch the x and the y. So the y becomes the x becomes the y. Then I need to solve for the new y. So I'm isolating the new y. Subtract the 7, x minus 7 equals negative 3y, and then divide by negative 3. And then we replace y with f negative 1 because we changed this. It's no longer y equals. It's f negative 1 equals. Now you can leave it like that, but if it's going to ask you to graph it, then you would want to separate that out. So you would want to put it in slope-intercept. So that would be the same thing as dividing them both by the negative 3. So negative 1/3 x plus 7/3. You can leave this answer. Like in WebAssign, this answer is totally fine. But if it says to graph it, obviously you need to put it in slope-intercept form. So you'd separate it out. Both are right. Yep. Questions so far? All right, so same thing with B. First thing we're going to do is replace the f of x with y. Then switch your x and your y. And now I want to isolate the new y. How do I get it out of the denominator? Multiply it on both sides. So these cancel. Distribute on the left, I'd get xy plus 2x equals 1. Subtract the 2x. And divide by x. So again, you can write it as 1 minus 2x over x, or you can write it as 1 over x minus 2. Either answer is fine. You do, however, have to change this to f negative 1 of x. So again, both answers are fine. If you were to graph it, you'd have to do the second one because that's your reciprocal function. So that would be a reciprocal function shifted down 2 places. Questions on either of those? So that's method 1, and if it says algebraically, that's what it means. Switch the x and y, solve for the new y, make sure you do the f negative 1 of x. The second way is actually taking your graph and switching your x and y's. We literally are taking our x, y's, and we are switching them. So any x becomes the y, any y becomes the x. You literally just flip-flop them. So if my coordinate points were 1, 2, 3, 4, then the inverse becomes 2, 1, 4, 3. So if they give you the coordinate points, just switch them. If you have to find them from the graph, obviously you're going to find them from the graph and then you're going to switch them. All right, then there's going to be a question that even says, can you have an inverse? Can this function have an inverse? Okay, so the way that the wording you're going to use is that it's a one-to-one function. If it's a one-to-one function, then it has an inverse, okay? If it is not one-to-one, it does not have an inverse. One-to-one means for every one x, there's only one y, and for every one y, there's only one x, okay? So think by saying one-to-one, we're saying two things. It's already a function, which means it passed the vertical line test, and now we're saying it has an inverse, which means it's going to pass the horizontal line test. So in order for something to have an inverse, a function to have an inverse, it has to pass both the vertical line test and the horizontal line test. So now, by words of the last time, a y cannot repeat with a different x. Like that kind of matches the words we did with the other. So to test for a function, the x can't repeat with a different y. To test if it's one-to-one, the y can't repeat with a different x. And that would fail a horizontal line test. If I drew a horizontal line, it would intersect that at more than one point, okay? Which means it's not one-to-one, and if it's not one-to-one, it can't have an inverse. Yeah. Oh. So now go back to the one we talked about before. Okay, this question, this was the first example. Okay. Focus on that bottom one. First of all, think about what f of x would look like. If f of x equals x squared minus 3, what kind of graph is that? It's a parabola, shifted, down 3. Okay, so if I drew this out, this is a function, it would pass my vertical line test. But if I drew horizontal lines through this, what happens? It fails it, right? So this makes it not one-to-one, which is why they added on this part. It's saying where it's greater than or equal to 0. So it's saying really the only part of this graph I want to include is this part because that will now pass your horizontal line test. Does that make sense? So in the homework for tonight, it's not going to ask you to create the restriction, but it will give you the restriction and just realize that's why it's there, okay? Same thing for the g of x. Like the g of x itself is what kind of parent function? Square root. What's the shift? Left 3. 1, 2, 3. I would have plotted it. This is fine. This passes my vertical line test. This passes my horizontal line test, right? But we're trying to find the inverse of this. So if I take and I flip it, it's going to cause the same. That's why that restriction, this, matches this restriction, okay? Not the same actual restriction. Like if you look, it says x has to be greater than negative 3. That restriction comes from I can't have imaginary numbers here. Does that make sense? So that's how they will both overlap. It's either going to be a restriction on the domain, like the one that's on the right. Technically, this graph is fine, but there would have been a restriction on the domain. Or on the left, where you have to restrict it in order for it to be one-to-one, okay? So again, I'm not going to ask you to find those restrictions. Just know that when they're in there, that's why they're there, okay? All right, so example 3 just says determine if it's a function. So this is one step because how do we test that out? The vertical line test. Then determine if it's one-to-one. And how do we test that out? Horizontal. So is a function? No. Yay, you're done. Go to B. Is B a function? Yes, it passes the vertical line test. Then we go to one-to-one. Does it pass the horizontal line test? No, not one-to-one. Then you go to C. Does it pass the vertical line test? Yes, so it is a function. Does it pass the horizontal line test? Yes, so it is 1 to 1. And the last thing says, if it is 1 to 1, graph the inverse. So there are no coordinate points on here. You are going to approximate, and it doesn't matter how you approximate because when you flip it, it will still be approximated, okay? So I could literally say like this is 2, and I would just make myself consistent in each direction, okay? Actually, it's probably the same. And then I just pick a couple points. So this one's easy. This would be negative 2, 0. This one's easy. This would be 0, 2. That's for my original function. So if I want to find the inverse, what do I do with those? Flip them. So I would want to make it 0, negative 2, and 2, 0. And what should happen is if you fold it along the y equals x line, they should be symmetric. Or y equals negative x the other way. If it's going the other direction, they should be symmetric. God bless you. Well, they're not all going to be lines. So yes, if it's a line, no, those won't be parallel. They eventually intersect because there's a curve on it. And they won't all be lines. Question so far? All right, so now think about this in terms of domain and range. Domain is what values? The x values. The range is your y values. So if it asked me to find the domain and range of my inverse, I would switch them. But this is simply saying determine if it has an inverse. So this goes back to like when we tested out a vertical, like your vertical line test. If you want to put these in coordinate point form, you totally can, okay? 1 goes with 80, so that would be 180. 2 goes with 80, 280. 3 goes with 100, 100. So first of all, it has to be a function. The x can't repeat with a different y. And then secondly, it has to be an inverse, means the y can't repeat with a different x. Is that happening? Yeah, so this is not, or it has no inverse. It is a function, but it has no inverse, which means it's not 1 to 1. Yes, I can't turn it off. I'd love to turn the hearing thing off, but I hear, yeah. All right, B. So compare your x's first. What happens this time? The x's are repeating. Is the y the same or different? Different, which means this is not a function. Yeah. Just the wording is weird. It would probably ask you like the last one, is it a function? If it is, does it have an inverse, to be honest? Yeah. And obviously if the x didn't repeat, then I would check the y's, and they don't repeat. So if the x didn't repeat, this would have even been 1 to 1. Yes?
If something is a function, it doesn't have to have an inverse.
Correct.
But like, it can't be an inverse without being a function.
It can't be an inverse function without being a function first. Yes. Yeah, it has to, because it can pass the vertical line test and still fail the horizontal line test. So a parabola is a function, but it's not 1 to 1, so it can't have an inverse. All right, this is how you determine from an equation. So from an equation, remember we checked the y last time, now we're checking the x. The x cannot be raised to an even power or be in absolute value bars, unless there's also a restriction. So this is what I mean. If on the left-hand side, it just said f of x equals x squared, is that 1 to 1? No, so it doesn't have an inverse. On the right side, it's f of x is x squared, where x is less than or equal to 0. Is that 1-to-1? Yes, it's restricting it to just 1/2 of that curve. So it would pass your vertical line or your horizontal line test. All right, last slide, last set of examples says determine if the function has an inverse. So these are easy yes, no's, right? A, yes. B, no. C, yes. D, easy stuff. And with 3 tries, y'all better get those right on Webaside. Okay. Those are good green checks. All right, speaking of, I have to schedule it for you, but you can use the rest of the time to work on it.